So, good morning, dear students. So, myself, Dr. Lingaraju, Assistant Professor, Department of Physics, Government First Year Degree College, Tumkur. So, today I am going to take sound class. So, it is relevant to 4th semester Physics in Tumkur University. This is the second unit of syllabus. Sound, we know in PUC and also in 10th also we discussed, we know about the sound. Sound is having a different kinds of formations or phenomena. So the introductions of this sound here we are going to explain initially using a one kind of a periodic motions. So that is the motion which repeats itself at regular intervals of time is called periodic motion. The revolution of Earth around the Sun is a periodic motion. Similarly, the revolution of Moon and artificial satellites around the Earth are also periodic motions. So here also we are going to explain using a periodic motion oscillatory motions. Oscillatory motions. So the oscillatory motions, a motion in which the body moves to find fro about a mean position is called a oscillatory motion. The motion of the bob of a simple pendulum and motion of a prong of an excited tuning fork are called example of the oscillatory motions. So here we are going to explain vibrations. So many different type of vibrations are there. We can also say simple harmonic motion is also one kind of a vibrations. So that is a simplest type of a periodic motion or oscillatory motions is called simple harmonic motions. A simple harmonic motion is defined as the motion of a body which moves to and fro along a straight line, such that its acceleration is directly proportional to the displacement from the fixed point and is always directed towards that point. That is simple, like that simple harmonic oscillations. The oscillations of the bob of a simple pendulum is an example for a simple harmonic oscillations. Here we know the characteristics of a simple harmonic oscillations. The motion of a body executes simple harmonic motion is periodic motion. Second is the motion of a body is to and fro motion along a straight line about a mean positions. Acceleration produced is directly proportional to displacement of the body. Third characteristics. Fourth one is acceleration is always directed towards the equilibrium positions. After knowing a general concepts of a simple harmonic motions, next year we come to the different wings, different forms based on a simple harmonic motion. Simple harmonic motions already we learned in basic PUC and also in the background of 10th. Knowing that, here we are going to come to the how many types of vibrations are there. Here we discussed two types. There is a forced vibration and also a resonance. First here we come to the vibrations. That is a forced vibrations. Here, in the vibrations, two types of vibrations are there. One is forced vibration and another one is free vibrations. We are also called as it is a damped vibrations. Damped vibrations. First we come to the free vibrations. Vibrations that occur in the absence of frictions. We can observe in the diagram. The vibrations that occur in the absence of frictions and external forces of an initial release of body, that is we call as a free vibrations. So from the a simple pendulum, just here it is going to rotate. From the simple pendulum we can observe. Second one is force vibration. So from the diagram we can observe simple, free and also force vibrations. When a repeated force continuously acts on the systems, so if you apply the force repeatedly, force continuously acts on the system, the vibrations are said to be forced vibrations. That is pendulum in a clock. We can observe pendulum in a clock. So like that it is moving this side and also that side using a one force repeatedly. Any external force has a overcome structure properties. It is a mass, stiffness and also a damping process. After knowing these force vibrations, so the vibration in which the body vibrates with a frequency other than its natural frequency under the action of a external periodic force. So such vibrations are called as forced vibrations. These vibrations are called as forced because the body vibrates with a frequency of external force rather than its own natural frequency. For this kind of a force vibrations, so we can observe example. Vibrations of floor caused by a running of heavy machinery. Observe ಮಾಡಿದೀವಲ್ಲ ನಾವು ಸೇತುವೆಗಳಲ್ಲಿ vibrations of floor causing by running of heavy machinery. Second one, vibrations of a car when running in an uneven road surface. Observe ಮಾಡಿದೀವಿ. Vibrations in reciprocating engines due to periodic reciprocating in pistons. So next is crosswind. Crosswind in a valley caused the bridge to resonate and collapse. That is also one. After knowing this one, here we know microwave ovens. Generally we are going to use this one, microwave ovens. Microwave ovens is natural frequency of vibrations of a water molecules. That is the frequency of microwaves. Natural frequency of vibrations of water molecules. That is microwave ovens. And also water molecules in food resonate and food gets eaten up. Next is body of the bus or motorcycle vibrates when it's traveling at a particular speed. That is a function of a vibrations. Continuation of this one, we know CT scanning, MRI, so many different kind of instruments what here we are using in a medical field. Magnetic resonance, that is a MRI, magnetic resonance imaging. It is also used in a medical diagnosis. Then these electromagnetic fields are varying frequencies cause nuclei of atoms to oscillate. Energy is observed by atoms in resonance. The pattern of energy absorption produces computer enhancement photograph. So these are all the applications we are painting vibrations. In a electrical circuits, radio receivers works on the principle of resonance. tuned to particular stations. Radio waves receives some frequency and electrical oscillations in circuit. Electrical oscillators are high amplitude and same frequency as the radio waves in the induced receivers. So then here we know. And also we have to discuss the resonance. What is the meaning of resonance? We know. Resonance means any body, any particular element, if they having a mass, they having their own its frequency. Their own its frequency. So this frequency is comparing with the any one another material, matching with the other material frequency to get the maximum. It is we called as resonance. So the definition of the resonance is the artificial frequency of the material is matches with the natural frequency of the materials. If these two will be matches, so we can get the maximum sound. We can get the maximum sound from the systems. That is we call as resonance. Using this resonance, so we are in detail we are going to do one experiment. That is a volume resonator. How here it is going to give the example for the resonance means here we are going to add a water in a complete mark of the particular vessel. It means maximum. So it means at that time there is no any air gap, air inside the vessel. So if it is not having any air means, so here any kind of a propagation of station waves does not traveling through in the medium. If you release the water from the vessel, proportionality the air will be going to occupy in the vessels. The air is nothing but one kind of a substance. The air having a certain amount of their own resonance, their own frequencies. Proportionality, we are going to use some tuning forks. The tuning forks depends upon the mass, arrangements, strength, caliber, brittleness. Based on all these things, they having their own frequency. If we comparing our tuning fork to the vacuum inside the jar, air inside the jar, what is the frequency of the particular air is there in our volume resonator is matches with our tuning fork. If we release the water continuously at the time of maintaining a tuning fork with a certain amount of vibrations at one particular instant of time, so we get or we heard maximum sound. The maximum sound is nothing but the resonance. How the resonance or maximum sound will be comes because of due to the air gap will be increases means the air strength will be increases means the frequency of that particular air will be going to varies. It is going to matches with the what frequency tuning fork frequency we are going to kept it on a 1 minute, sir. Okay, sir. But it's nice. Thanks. So resonance, it is matches with a particular point. That is we called as a resonance. Natural frequency of the air is matches with the artificial frequency of the tuning fork. That is we called as a resonance. That one is also here we are going to discuss. If you are take a guitar string and stretch it to a given length and a given tightness and pluck it, we would hear a noise, but the noise would not even be close in comparisons to the loudness produced by an acoustic guitar. To the other hand, if the string is attached to the sound box of a guitar, the vibration string is capable of forcing the sound box into vibrating at the same natural frequencies. So next one more another example. The sound box in turn force air particles inside the box into vibrational motion at the same natural frequency as the string. The entire system begins vibrating and forces surrounding air particles into vibrational motion. The tendency of one object to force another adjoining or interconnected object into vibrational motion is referred as forced vibrations. Next, just we are comparing the differences of forced and free vibrations. Free vibrations are of a body in absence of any external force. Vibrations of a body in presence of an external driving force. If the absence of body is in presence of body. The free vibration frequency of vibrations depends on the source of vibrations. Either the frequency of vibrations depends on the source of vibrations and the frequency of the driving force. Both. Next, frequency of vibrations remains constant. Free of vibrations. Forcefully, it will be going to changes depends upon the force. Amplitude of vibration is also remains constant the vibration, but here whatever the free applied in increases or decreases changes take place. Depends upon the what kind of forces here we are going to applying from the external field. After knowing these two things, so we come to the resonance. The word resonance comes from Latin and means to resound, to sound out together with a loud sound. The phenomena, what I said earlier, the phenomena in which an external force or a vibrating system forces another system around it to vibrate with a greater amplitude at a specified frequency of operations. So, demonstration of a resonance with a tuning forks. Resonance can be demonstrated by the help of two tuning forks of same frequency bound to two tuning forks upon two separate sound boxes such that their ends. So earlier what I said, similar type of examples. Continuation of this one is strike out in a tuning fork. It is observed that the vibrating of a loud sound is heard. This happens because the sound waves from the first tuning fork forces a resonant vibrations in a second tuning forks. So of knowing these things, resonance and its examples. So what I have discussed, what we are observed through a examples about a vibrations. In the vibrations are two types, free and also a forced vibrations and also a resonance. I referred so many different kinds of books, that is Sundarajan, written by Sundarajan author in a college physics, and also Subramaniam author through the textbook of optics, and also Mangala Gauri through a undergraduate physics waves, optics statistics, and also Nagbhushan Next. They are also using a handbook of physics, and also Ramakrishna ji. So observing all these things, I referred, I written the notes and also a PPTs. Through these PPTs, I am going to demonstrate these forced vibrations and resonance. So, if you want, I will explain once again the resonance. Repeatedly once again, because it is a very important concept. When an external periodic force is applied over a body, it executes forced vibrations with the frequency of a force. However, if the frequency of external force is equal to the natural frequency of a body, then the amplitude of forced vibrations becomes very large. This phenomenon is known as resonance. When the frequency of external force is equal to the natural frequency of the body, then the vibrations of maximum such phenomena is called resonance. So there is a definitions. So I will give some example for the about this explanation. When the frequency of the external force is equal to the natural frequency of the body, then at instant of the force in the space with the vibrating body, the successive impulse given by the periodic force to the body add up. This will increase the amplitude of vibration continuously, but with increasing in amplitude, air resistance and internal frictions also increases. Finally, a stage is reached when energy supplied by the force becomes equal to the total energy of the body. If there were no losses of energy, the amplitude will become infinite. So it's about forced and free vibrations and also a resonance. So actually in continuation of this theory concept, in the lab also we are going to do one experiment. That is a volume resonator. What I explained, it is one kind of a very interesting experiment. In PUC level, we are calculating the frequency of a tuning fork using a 2 or 3 different kinds, using a vibrating string, using a electromagnetic radiations, or using a Meldage experiment. So many different ways are there. Here also we are going to calculate the resonance. Using a resonance, we are going to calculate the frequency of a tuning fork using a volume resonator. So this volume resonator, it is a very simple experiment and also a very experimental thinking experiment. How here we are going to calculate? Based on this kind of a experiment, so we can easily calculate any kind of a solid material frequency. That is the one very important applications what here we are getting from this experiment. So from the tuning fork means they having a different frequency range of objects. From the tuning fork, we are going to calculate what is the frequency of the particular tuning fork. Proportionality of a gap of the air inside the volume resonator. So if it is matches, it matches with the air matches with the tuning fork in a different level because of they having a different frequencies. So it will be going to coinciding. Where it coincide? What coincidation? The frequency of the air. The frequency of the air is coinciding with the frequency of the tuning fork at the time of vibrations released from our tuning fork. If these two will be matches, so we are getting a maximum sound. We heard a maximum sound from that particular experimental setup. That sound itself is here. We are going to count down the frequency of the tuning fork is matches with the frequency of the water molecules, water air gap. So knowing this one, so we are going to stop the releasing of water. And what amount of the water is collected? It is directly proportional to the strength of the air it is there inside the jar. So knowing the resonance relations, one formula is there. Volume resonator, one relation is there. So knowing that resonance relations, so here we are going to calculate. So the frequency of a given tuning fork using that materials. Similar way, here also you can easily calculate any kind of materials resonance. ಯಾವುದೇ ಥರದ ಮೆಟೀರಿಯಲ್ಸ್ ರೆಸೊನೆನ್ಸ್ ನಾವು ಇಲ್ಲಿ ಕಂಡುಹಿಡಿಯಬಹುದು. ಸೊ ಇಟ್ ಈಸ್ ದ ಒನ್ ಕೈಂಡ್ ಆಫ್ ಎ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಹಿಯರ್ ವಾಟ್ ಹಿಯರ್ ವಿ ಆರ್ ರೀಡಿಂಗ್ ಫ್ರಮ್ ದ ಸಿಸ್ಟಮ್ಸ್. ಸೊ ಇಟ್ಸ್ ಅಬೌಟ್ ಅವರ್ vibrations and also a resonance concept. Thank you one and all. Next class we will discuss one more another topic. Thank you.